I'm not a religious guy, but there are some weird things out there that the mineralizations for this stuff, it's got phosphor that we desperately need for fertilizer. It's got rare earths that we desperately need for advanced technologies. And it comes with the fuel to run it all. You know, it's got the thorium. I mean, that's pretty good. Somebody put those three things together in one little rock. I'm John Kutsch. I'm from the Thorium Energy Alliance, executive director. I was running an engineering consultancy, and I had a client. He had a process that he wanted to find a replacement material for because, well, kind of like this, he was having trouble sourcing some material. And I knew, you could tell, he was just had a periodic table in front of him, and he was just running through it. He's like, "Will tin work? Will cobalt work?" No, and we'll look into it. Eventually, he worked his way all the way to the end of the periodic table, and he's like, "Will thorium work?" And I'm like, "God, I never even heard of that shit. You know, what is it?" And I'm like, "I don't know. Let me check." And it was incredibly fascinating for obviously one of the big uses that a lot of people get very interested in is energy. I put together a conference in October 19th of 2009. All the thorium enthusiasts were all like ex-lab guys and propeller head guys and tech guys. I knew what it was like to lobby Congress, and I knew to try and get to the staffers, the ones who, you know, guide policy. And so that's why I held the first conference in Washington at Gallaudet. You know, we had some training there. But I announced a conference, threw down thousands of dollars, and then I had to find people to speak. Calling all these guys, and I called Jim, and I'm like, "Hey, Mr. Kennedy, will you come and talk at my conference on thorium?" And I just heard this like, okay, you know. And
I was going to be there anyway.
Yeah, it turned out it was a total fluke. I'm ashamed to say, as the head of the Thorium Energy Alliance, I knew a lot about thorium, except kind of like where it came from, you know. And we're also, you know, unashamedly very patriotic, Western-leaning guys. I would slave to get stuff made in America, you know, manufactured here. So when Jim came and said, "Hey, you know, I've got this rare earth deposit on my mine, and it's riddled with this filthy junk called thorium. You know, what do I do with it?" We had a whole group of guys who just, you know, were like salivating dogs. You know, they're like, "I know exactly what you can do with it." And of course, the vast majority of them wanted to start reactor companies and design reactors. And the most favorable reactor form that we can think of is a molten salt type reactor. The reason that's so attractive is that 50 years ago, Oak Ridge National Labs actually built and ran for 23,000 hours a molten salt reactor. So it wasn't a paper reactor, it wasn't some fantasy. So for 9 years now, I guess, we've been pushing this idea of the cooperative. Now we call it a thorium bank because it helps policymakers get it. We're storing this for use at a future date, sort of thing. So it's a strategic reserve, really. But thorium isn't very hard to handle to begin with. It's a light alpha emitter. You could have 1,000,000 pounds of it in a pile and nothing's going to happen because it's fertile, it's not fizzled. It needs an external neutron source for it to go from thorium-232 to a species of uranium called uranium-233. And so it's got a lot of attractive features, not least of which you get it for free when you process rare earths, and there's no such thing as highly enriched thorium. Thorium is good to go. Jim Kennedy from 3 Consulting is going to talk about the rare earth situation here in the Western world.
The United States mining industry throws away enough recoverable rare earths every year to meet the entire non-Chinese demand. In fact, if we exploited everything that was recoverable from existing mining, we could actually probably meet half of China's demand, in addition to the non-Chinese world. Where do these magic free rare earth materials come from? Mineralizations called monazites, xenotimes, and apatite. And what they are is phosphate-based minerals that have a real affinity for all of the rare earths. And as you go from the light ones to the heavy ones, this guy shows up, thorium. And thorium is always associated with rare earths. There's one exception, which are called the ionic clays in China. And I'm pretty darn sure no country in the world would let you mine them the way they mine them outside of China, so it's not an option. These materials still exist, they're still being thrown away, and they're being thrown away because of a regulatory snafu from 1980. Now, we all know that members of Congress don't like changing regulations, and they certainly don't like changing regulations for radioactive materials, because some group somewhere is going to take that as a threat to safety, a threat to whatever, or a way to raise funds when they scare people. So what do? We work within the regulations. The rare earths are pulled out and utilized. The other material goes into the thorium bank. This is Bayan-Obo. It's the largest rare earth mine in the world. Over 50% of China's rare earths come from this one mine. How does any U.S. mining company look you in the face and say, hey, we can mine cheaper than China? Really? I mean, it's so disingenuous, but they'll do it with a straight face. Over 50%, it has no direct mining cost. These are the ionic clays. These are really important, but China actually has a very short future in these. These won't last much longer. This is what Mountain Pass produces. There's a lot of zeros here. That means you're not getting any of these very, very important heavies. They've actually never produced a commercial gram of this. They've never produced a commercial gram of this. So it's zeros from here on down. This is the stuff we're throwing away every day when we mine titanium, or zircon, or rutile. This is a respectable amount of heavies. The Linus deposit in Australia, which ships their material to Malaysia to be processed, their quantity of heavy rare earths is 0.3. 0.3, not 3%. And that's really a whopping advantage over Molycorp, who has 0.1. So when they say we're making heavy rare earths in Australia or Malaysia, I mean, really, you can run an economy on that? No. And the reason they're so naked here is they're trying to avoid thorium. And when you avoid thorium, you get dumpster stuff. I mean, this is really not good stuff. This is what we're throwing away. This is a selected apatite. These things you'll find in the tailings of iron ore. So if you're mining iron ore and you're cleaning the iron ore up enough that you can make quality steel, you actually are forced to strip this out. And in the process to strip it out, you concentrate it. So it comes out just like this. These are very respectable numbers. Okay, this is the really sexy one over here. Florida phosphates. Florida phosphates, they're producing fertilizer for the food we're going to eat for the next 100 years. And for the next 100 years, they're going to keep throwing this away unless we fix this problem. And according to a USGS report by a guy named Paul Emsbro and about 6 other USGS guys, they said just 6 US mines mining phosphates could meet 65% of the world's demand. And we're throwing it away. These guys represent the phosphate industry. It's University of Southern Florida, and this is the Phosphate Institute. Basically, it says this one mine throws away 22,000 tons a year. That's roughly 2 times US demand. Let's say you could just get half of it, which is a reasonable number in mining. It's a kind of a low-end number of mining. That's 100% of US demand. There's 5 other mines just like that. So this number keeps getting bigger and bigger as you add them in. Estimates on production of monazites with dates, 6 to 12 months. Doubling that capacity, 12 to 18 months. That's how fast we're producing monazites that literally run between 50 and 60% rare earth. And if you remember, they're very attractive, they contain all the good stuff. As you can see, you can have reasonable tonnages almost instantly. So if you look at
have thorium?
They do have thorium, that's why they're throwing them away. So the only way to get an uninterruptible supply is to use the historic supply that fed this industry for decades and just be reasonable. This stuff literally will come free, but we've got one problem, we've got one liability we have to deal with. All of them have thorium, and that has to be dealt with within the regs, which means as it passes through the value chain and we strip out our rare earths, we're still responsible for dealing with that thorium. We transfer these over to the thorium bank and they comply with all NRC IAEA guidelines. get out of bed, put your big boy pants on, and manage that liability, because if you don't manage it, you know what they do with it? They dump it into a legal tailings reservoir. That's actually the environment. That thing is connected with waterways and fish and trees and everything else. No matter what you call it, they're dumping it in the environment. And so if you want cleaner, better mining, let's just do it right.
When you create rare earths, essentially you're doing something along the lines of titrating, right? And so you have this liquor, and the rare earths are coming in this liquor, generically, maybe it's powders or gas, there's lots of different ways to skin the cat, much more efficient and clean ways, I should say. Jim and I have been sponsoring and promoting and helping guys do research in clean rare earth separations for years now. But the thing is, it falls out heaviest to lightest. So the first thing that would fall out would be what? Uranium, if there's a little bit of uranium in there, and there often is in other mineralizations like xenotime and such. But the second thing to fall out, thorium. What we say is we literally, as it falls out, literally gravitationally falls out, we're there of the catcher's mitt. We would concentrate it, and then we would encase it in a phenolic resin, so we wouldn't get any radon. That's to contain any radon from the decay of thorium. And these balls are pretty big, so they're about the size of a basketball, and it's literally too heavy to steal, all right? So the thorium is heavy as hell, right? I mean, a little ball of it that big weighs 19 pounds. So a basketball size of it. We have a building seismically isolated inside a building. And then we stack these balls in stainless steel casks, the same casks that you'd store spent nuclear fuel in. So again, you could have them in your as door stops. I mean, there's no reason for any of this other than then these casks are cryogenically chilled to 40 degrees below zero, because that's the temperature at which radon becomes a liquid. And so we have all sorts of sensors, we have all sorts of refrigerants. We did this with PNNL. This thing is so clownishly overbuilt because we really understand that the public is rightfully concerned that people aren't honest with them. And so we want to really go overboard with the safety. So when you go to that length to store something safely, somebody's going to do the jujitsu on you and be like, well, it must be really dangerous if you're doing that. And so it's sort of like you can't win for losing, and because it's like you're trying your best to allay any fear, and somebody will use that against you to stoke fear. What else are you going to do? So how does all this get paid for? So this is the part that policy people would really want to perk up at. Thorium Bank is also, you could call it like a garbage service or a sin eater. We are going to take thorium, which is the one thing that keeps rare earths from being processed in the United States, and we're going to, through the executive order or through Rubio's bill, what we do is sever the liability, joint and several liability, and we take it on.
What it offers is a multinational platform, and that we are in contact with parliaments around the world where there are parties, including green parties, who are interested in developing this. It's basically an open platform for all of our friendly partners to invest in. That
bank charges a fee. We don't do it out of the kindness of our hearts. So every kilogram of thorium gets taken in. And let's say, just arbitrarily $35, and the lifetime perpetual care of that kilogram is going to be $10 or $20. There's a margin there that we can use as you make thousands of tons of rare earths. You almost get as much thorium as you do rare earth out of these mineralizations. You'll accumulate an account, and that account, that is the magic of this, is the millions of dollars in that account. Once again, we don't go with our hat in our hand begging the DOE or the NRC to fund reactor development. We know that that's a very fraught thing. We have excellent programs like GAIN and programs like that, and the best national labs in the world. But we can privately fund research and development, and we don't pick winners and losers in that either. Somebody comes, they ask, for funding, I would expect that it would be grants. But you could also, think of other funding mechanisms. Yes.
We are in contact with governments who sent members of their parliament to our conferences to express their interest to directly invest in this. You're not just getting thorium, you're getting uranium.
Mm-hmm.
And why would you hold the uranium? It's got a market.
Yeah.
So you would sell that uranium into the energy market. That would generate meaningful revenues. So you would have a steady flow of cash from uranium sales, and you would have member states buying into this. And when you have all of your member states buying in, the sale to them is, we can all own this reactor technology together, or China is going to beat us to it, and we're going to be buying their reactors because China has an 8-year head start. Our DOE literally handed them every single thing they need. They literally gave them the day-to-day operational manuals of when they were running the reactor. They actually tasked our universities and national labs to help China develop this reactor. On the thorium side of this, you're going to be going out and you're going to be meeting sovereign countries, just like on the cooperative side for rare earths. You're going to say there's a rare earth threat, there's an energy threat, and if you guys all work together as governments, you will be guaranteed top line revenue for this thing forever.
There is boogeymen out there. China does have an 8-year head start, and they've built a huge supply chain. They're not idiots. They didn't just build a reactor. Anybody could just copy the blueprints of the reactor that we built in the 60s and build it again. But then you got a reactor. They've got thousands of people and a multi-year commitment, and they've got a nuclear graphite factory, and they're making all the super metals, the hastelloys that they need. They've got a salt production facility. They've got 5 working salt loops, and in 6 months they're going to turn on their first 2 megawatt, very modest but very good, more than we have, 2 megawatt thorium molten salt reactor. And so there really is fantastic, unbelievable promise in the idea that when you process rare earths, I'm not a religious guy, but there are some weird things out there that the mineralizations for this stuff, monazite, xenotime, apatite, it's got phosphor that we desperately need for fertilizer. It's got rare earths that we desperately need for advanced technologies, and it comes with the fuel to run it all. It's got the thorium. That's pretty good. Somebody put those 3 things together in one little rock. You go out in the world or you read the paper, and it is utterly unpleasant, right? We've got a young kid over there that we've effed up her world, and she's going to be stuck working on it. My nephew just had a couple kids. Jim's got some beautiful girls, and everyone who has something to look forward to in the future has to be really dejected by the trajectory we're on. But I don't see it. I see a future of energy abundance, and energy equals wealth, and energy is what brings people out of poverty. And not only can the United States replace and decarbonize and have an even better, more prosperous world, we can lift billions of people out of poverty. And we can do it on the back of thorium and on garbage. And so I think the opportunity to use thorium is the most utter optimistic thing you can do to lead to a world of energy abundance forever, for thousands of years. We have thousands of years of thorium available to us. Yes.
So does Rubio's bill punch all these holes that you have?
Yeah,
it looks pretty good to me. The very title of it is the Thorium-Bearing Minerals Rare Earth Cooperative. It's got thorium right in the title, so yeah.
Yep.
Encourage you to do whatever you can to get that bill passed, or if, at the very least, if all the bill does is gets the executive to take executive order action, well, that would be great, because the bill is symbolic of support in the Congress.
And as far as commerce, Navarro, how much support are you getting from that side?
There's been a lot of
We can't speak for their
privately,
support.
but
They're all listening and interested. That's all we can
Yeah,
say.
they listen to what we have to say. So.
you know what, if the United States Congress, the House and the Senate will pass a regulation that mirrors an executive order they have, then what you're sending the president is bipartisan, bicameral support to do this, and it takes all the risk out of it for him. And there's no risk because you're asking foreign corporations to build that cooperative. You're asking them to commit to building an entire value chain in our country, but we're going to be the primary beneficiary of it. And what they're going to get for it is an uninterruptible flow of those materials. We're going to turn rare earths into a utility. It's going to be no different than the electrons coming through there, because those electrons coming through there make the entire world work. And we've done that through utilities because we see that when you give people guaranteed low-cost flow of basic things, that they can get very productive. And if we do that with rare earths, we're going to have an explosion of opportunity to develop technology. And if we take the other route, which is a route where we say, hey, we're going to give you guys subsidies, and their $6 maggot costs $6,000, then it's going to be the end of innovation. The only way we're going to nurture innovation is turn this flow of materials, just like those electrons, just like the highway system, into a public utility so we deliver them cheaply so to the other side they create prosperity.
Jim, you were talking about how China had been developing this capacity since the mid-'80s, if I remember.
Yep.
So what do we know, for example, about China's thorium bank?
They actually admitted to how much they had, but
It's gobs.
it's huge. But they keep it in what amounts to, they keep theirs and they're right to do this because it's not bad. They keep it in the form of thorium nitrate in sacks stacked to the roof inside what it looks like giant Morton buildings, and they know.
Sandbags.
Yeah.
That's why they're developing the thorium molten salt reactor. I need to very specifically,
My question.
hold on one second. I need to very specifically say something about molten salt reactors, as the Chinese like to say, not picky eater. There's molten salt reactors that are designed to run thorium. There's molten salt reactors that run uranium tetrafluoride. I support molten salt reactors, and I really like thorium.
Once you get into politics, it's not clarity, it's unclarity. Yes, he's right. By the way, the same reactor can be designed to do nothing but eat nuke spent fuel sitting in parking lots.
Why the Chinese, who have this 30-year head start on separating thorium, why wouldn't they put it into the market and use that to basically
It's worthless.
undermine your
Yeah.
U.S. thorium bank? Or
Thorium has no market right now because the people who use it, it's so tiny that you can't sell it. It has no market. And even if we're running thorium nuclear reactors from coast to coast around the world, that thorium is still going to be worth about zero.
Think of it as yeast, right? There's yeast in the air. There's no value to it. There's value in what you do with it, right? So you make beer, you make penicillin. The United States buried something like 50,000 tons of thorium nitrate. Because we used to think, shit, we better start stockpiling this stuff. The French have a similar amount, just a huge stockpile of thorium nitrate because the French used to be huge separators of rare earths. And so the Chinese now. But the fact is, that is enough fuel for 1,000 years.
right, I'm trying to understand the value to the cooperative.
So what the thorium bank's primary purpose is isn't even to physically store the thorium or hopefully to fund research in thorium. The primary thing that the bank does is it eats the liability, right? So let me tell you a super tiny story. Anadarko bought a company called White Industries. White Industries bought another company, and that company bought another company going back 130 years that used to make thorium lantern mantles in Naperville, Illinois. $800 million liability. That's joint and several forever and ever. And so part of what we're able to do as a thorium bank is to go in and cut that. And so now a company like Aluka, who would give us monazite from a titanium mine, or a company like Mosaic, who would give us monazite or apatite from a phosphate mine in Florida, whatever source it is. Right now, there's no incentive for them to give it to us because it would still be on their books. And part of what we can do is cut that liability. You take your liability, we are crazily safely store your physical, and we are able to use the proceeds to fund advanced research without asking the federal government for any money. I really thank you guys. You've been exceedingly kind to spend so much time listening to us talk about this unbelievably important topic. And so thank you very much. You're free to run screaming from the room.